Lesson 8.2, Motion Graphs and Slope. So far, we've looked at two graph types, a dt graph and a vt graph. Both of these graphs on the screen are linear graphs, which have the equation y equals mx plus b. However, since they both go through the origin, the y-intercept b doesn't matter. So the equation we would use is y equals mx. For the dt graph, the equation is y equals mx, but on the y-axis is d, and on the x-axis is t. And we know the slope of a d versus t graph is speed. So that means the equation of a dt graph that's linear is d equals v times t. For a vt graph, the equation y equals mx tells us since v is y, and x is t, and m is acceleration, the actual equation for a linear graph on a v versus t graph is v equals at. Here's an example. It's best to pause the video now to draw out this example and then continue. To calculate the slope, there's going to be several steps. The first step is to pick any 2 points that must be on the line. I'm going to underline this because it's going to be important. It is best to pick 2 points that are on crosshairs or places where the grid lines cross. You don't actually have to pick points that you've plotted yourself, just pick 2 easy to find points actually on the graph. For example, this point and this point are both good points on crosshairs on the graph. Pause the video now to take a moment to find your points and label these points point 1 and point 2. It's easiest if you label the top point 2 and the bottom point 1, but it's not necessary. Find the coordinates for the 2 points you've chosen. Remember that when we write out coordinates, x is listed first and y is listed second. The coordinates for the second point are 30 and 16, where 30 is the x and 16 is the y value. For my graph, the coordinates of the first point are 10 and 4. Here's the 2 points again, 30 and 16 and 10 and 4. The next step in calculating slope is to calculate the slope using the slope formula. Slope equals y2 minus y1 over x2 minus x1. On my second point, x2 and y2 are labeled. On the first point, x1 and y1 are labeled. Slope of this graph is equal to 16 minus 4, the 2 y values subtracted, divided by 30 minus 10, the 2 x values subtracted. Now, if we were in math, we would write this as a fraction and leave it. But in physics, don't do this. Don't leave the slope in fraction form. Calculate the decimal to find the actual answer for slope. In this case, slope is 12 divided by 16 is 0.60 meters per second. It's really important that you notice that I preserved the significant digits given on the graph. So we have 2 significant digits in the slope I calculated. And Units are given in the slope calculation as well because the slope has meaning. The slope is speed. Here's another example. There's a data table here, and I suggest you pause the video to write out the data table in your notes. In this example, you will plot the data on the graph and find the slope of the best fit line. We start when we're always plotting a graph by labeling each axis. We label the y-axis as v and give it the unit meter per second. The x-axis t with the unit seconds. It's very important that you always label the axis, saying what's being plotted on that axis and which unit you are using. Don't forget to write the unit. This graph has the title Velocity as a Function of Time. Make sure that you always give your graph a title. Next, we pick a scale for each axis. It's good to pick a scale that goes up in easy to think about numbers. I like 5s and 10s, 2s, and multiples of these. Make sure that you pick a scale that allows you to spread out the data evenly over the whole grid that you have. So this way you can see quite clearly what's going on without scrunching it up. In each of the scales I've chosen, I've gone up in 5s because this allows me to spread out all the data and keep it even. It's recommended that you go up in evenly spaced intervals that are easy to calculate. It's always best to go up in 1s if it's possible, but 2s, 5s, 10s, 20s, and 25s are also useful. Next, we plot the data on the graph. You have to be careful as you're plotting the data to make sure you accurately put it in the right place. Of course, there will be some precision error, but you do your absolute best. After you plot the data, you need to draw your best fit line. To do this, you need a straight edge, like a ruler or the side of your driver's license or the side of your ID card. My best fit line isn't going to be perfectly straight, and that's because I don't have a ruler on the drawing program I'm using. So pretend that green line is straight. This green line represents a best fit line. This is a straight line. You must use a ruler or some other straight edge that goes through as many of the points as possible. You don't have to go through all the points, but you do have to go through as many as possible. You want to try to keep the same number of points above and below the line as possible. So your best fit line should have the same number of points above and below it that are off the line. Next, we calculate the slope of the best fit line. Make sure that you pick 2 points that are actually on the line. Don't use data points that you plotted but aren't on the line. Pick any 2 points that are on the line that you've drawn. I'm going to pick this point and label it 2, and this point and label it point 1. I chose these 2 points because they were on handy crosshairs for the graph. My second point has the coordinates 27.5 and 37.5. My first point has the coordinates 7.5 and 10. To calculate the slope of the line, we do y2 minus y1 over x2 minus x1. This is 37.5 minus 10 divided by 27.5 minus 7.5. The slope of this graph is then 1.4 meters per second squared. Again, make sure your slope has units. We're also going to look in this lesson at the meaning of the y-intercept on a graph, because some of your v versus t and d versus t graphs will have a y-intercept. First, let's look at a v versus t graph by examining the equation a equals vf minus vi over t. This is rearranged as vf equals at plus vi. Now, let's look at a v versus t graph that has a y-intercept. This graph has the equation y equals mx plus b. If we put this rearranged version of our formula right underneath it, vf equals at plus vi, we can see the connections that are being made. On the y-axis, we've plotted v. This is vf. The slope of the graph is the acceleration. The slope of a v versus t graph is always acceleration. The x-axis, we've plotted t. That means what's left, the y-intercept, must be the initial velocity. So the y-intercept for a v versus t graph is the initial velocity. You can also think of this as the velocity at time equals 0, which is the velocity it started with. For a d versus t graph, the y-intercept also has meaning. Here's a d versus t graph. On a dt graph, a y-intercept tells you where the object was at time equals 0. This is the original location of the object, where it started out. So on a d versus t graph, the y-intercept represents the original location or the start location of the object.